Hi all. In this video we're going to be examining an addition reaction to an alkene, starting with a common example of adding HX, something like hydrochloric acid or hydrobromic acid. For the purposes of our discussion, we'll be using an asymmetric alkene like 1-butene, and we'll be reacting it with something that generically could be written as HX. And of course here the X is any halogen, so we've got HCl or HBr are the two most common ones. The reason that this one's interesting for us is because this molecule, along with the other ones that we're going to discuss, can be shown to have a polarity to it, where in this case the hydrogen end is somewhat positive and the X end is somewhat negative. In this reaction and all the addition reactions we're going to talk about, the first step is using the pi electrons of the double bond as a nucleophile to attack the hydrogen and pushing the shared electrons towards the X end, or the negatively charged end. And that will give us now two items in our transition state, indicated by brackets here. The organic molecule will have the hydrogen attached to one of the two carbons of the former alkene. Markovnikov's rule tells us that the hydrogen will attach to the carbon that had more hydrogens attached to begin with. Or, put another way, the hydrogen will attach in such a place to give us the more stable carbocation, in this case a secondary carbocation instead of a primary. The other piece that we've produced now is our liberated X-, which will serve as a nucleophile in the second step. In that second step, a pair of electrons from the newly created X- can attack the carbocation intermediate, giving us our final product, which shows our carbon skeleton with H and X added to the two carbons of the former double bond. We'll see this same mechanism occurring again and again as we talk about different reactions. If we look at our HX, which we've just talked about adding, or later we look at water, we see a case where the small molecule that's being added is a polar molecule, with the hydrogen end being somewhat positive and the X halogen or the O being somewhat negative. Mechanisms virtually identical. We'll also see similar mechanisms using polarizable molecules like hydrogen or a dihalogen like chlorine or bromine. In this case, that first attack would occur to one or the other end of the molecule, liberating the second end, and that second end would serve to attack in the second step. This simple mechanism is going to be used again and again and again throughout this chapter, so take a moment to study it, practice, and we will talk again soon.